Hey, algebra students, we're looking at 10.5, absolute value in open sentences, equations, and inequalities. So just reminding you that when you have absolute value, you're looking at the possibilities of one solution. When we have the absolute value of x being equal to 0, then there is one solution, and that solution would be 0. Or absolute value of absolute value being equal to a negative value is no solution. So one solution or no solutions. And the other possibility is that when we have the absolute value of x being equal to a positive number, then we end up with two solutions. And in this case, that would be negative 10 and 10 as the possibilities. But sometimes we have the absolute value and the x is not all by itself inside of that, so we need to take a look at that. What we're really asking by asking the absolute value of the sum of x and 4 being equal to 10 is which numbers are 10 spaces away from negative 4. So you have to kind of think about that, and that's an equal to, so we're looking at kind of a union of ideas that you could have in order for that to be true, that x plus 4 could equal 10, or we'd be looking at the values where x plus 4 is equal to negative 10. And so we can solve those equations. We'll subtract 4 from both sides there on the first equation, and we get x is equal to 6. Or the numbers that would work would be x is equal to negative 14. So the values that would work in there are negative 14 and 6. So if we're thinking about, what are 10 spaces away from negative 4, it would be negative 14 or 6. So we have those two solutions. So we have some possibilities to think about. When you see equal to or an equation, you want to think of the word or we're thinking of union. And when we see greater than or equal to or greater than, we want to think or, again, or union. And the hint for that, sometimes we just want to point out, is that if you see the greater sign, we want to think greater. So greater than sign, you think greater, and you want the or value. And then when we have the less than sign, we should be thinking of and or intersection. And our hint to that, sometimes we refer to as less than, and instead of less than, we make it less than as we're kind of thinking through things. So when we're looking at just the basic absolute value of x being greater than 10, we're looking at or. So the values are going to be either this or that in order to qualify. And so when we're kind of thinking through that, we could have our 0, we have 10, we would have negative 10. And so if we want our values to be more than 10 spaces away from 0, for that, I'm just going to make that a little bit further away. Then what we're looking at are all the values greater than 10 spaces away. So that would be an open circle on 10 and looking at values to the right. But then the other values that would be more than 10 spaces away would be the values beyond negative 10 and shading to the left. So looking at those, how you could write those possibilities that, okay, so x is greater than 10, that makes sense, but then x could also be anything less than negative 10. So just pointing out that when we look at the other possibilities, we have flipped the relation symbol and written the opposite number. So flipping the relation symbol and writing the opposite number to kind of look at the other possibilities. So when we have the sum of x plus 4 being greater than 10, again, that's greater than, so we're thinking of the word or, and we want a union of sets there. I want all numbers that are more than 10 spaces from negative 4. So our possibilities is like just our original x plus 4 greater than 10, or we want values that x plus 4 is less than negative 10. So again, a flip of the relation symbol and the opposite number. Then we solve both those inequalities. So we get x is greater than 6, or, then we solve the other inequality, x could be less than negative 14. So the things that will make this true are the values of x that are greater than 6 or the values of x that are less than negative 14. So we can graph those. So I'm putting my values kind of approximately there. They might be on the number line. And I want values that are greater than 6. So an open circle on 6 greater than shading over to the right, or less than negative 14. So open circle on negative 14, less than shading to the left. Now when we're looking at the absolute value of x being less than 10, we're looking at and. So we're thinking of an intersection of things. So to graph that, we want all numbers that are less than 10 spaces from 0, less than 10 spaces from 0. So we've got 10 spaces on the right, 10 spaces on the left, and we want all the values that are less than that. So we would want an open circle on 10, an open circle on negative 10, and we want all the values in between. Now again, let's look at the inequalities that would make that true. So we have the original here, like x can be all the values less than 10, or and we want all the values that where x is also greater than negative 10. So again, looking at the alternative, we're flipping the relation symbol and writing the opposite number. And we want the values that qualify for both, that it qualifies under this inequality and this inequality. So when we have the absolute value of the sum of x plus 4 being less than 10, again, less than, we're looking at the word and. We want the values to qualify for both. And so we want x plus 4 to be less than 10, and we want x plus 4 to be greater than negative 10. So there's that flip of the relation symbol and the opposite number. We're going to solve the inequalities. I get x being less than 6, and I want the other, has to qualify for the other possibilities as well. X being greater than negative 14. So when we graph, we would want all the values here, open circle on x is less than 6, and less than would be shading to the left, and an open circle on negative 14, and greater than would be shading to the right. So we want all those values in between, all the values that are less than negative 6 and greater than negative 14. So they qualify for both. So in this next example, where we see the absolute value bars in the problem, and we do want to look at like our alternatives and our language, but we're also noticing that the absolute value bars are not by itself. And so I just want to point out in this that it's important that you isolate or get the absolute value bars by themselves before you decide whether or not it's and or, and before you look at your positive and negative possibilities. So we want to focus on isolating those absolute value bars. So to do that, I'm going to subtract 2 from both sides. I get 4 times the absolute value of x. is less than or equal to 6. Then dividing both sides by 4. So I get the absolute value of x is less than or equal to 3 halves. You could write that as a mixed number or as a decimal value is fine. But here is where we're deciding that, okay, I want to look at my possibilities. I have x being less than or equal to 3 halves. And then my other possibility would be x being greater than or equal to flipping negative 3 halves. And because it's less than, I am looking at and. And then I want to graph those possibilities. Excuse me. So we've got 0. I'll just put 3 halves on there. Negative 3 halves. And I want the values that are and. So I want them to qualify for both. And it's or equal to on both ends. So a closed circle on both ends. And I want those values that are less than 3 halves and greater than negative 3 halves, so I want the values in between. So the next example we're looking at is an equation, and so when we're looking at an equation, we're talking about or, and we are talking about disjunction. So we're looking at a union of things, and we still have our possibilities here. So we would have 2p minus 3 is equal to 7. Just should be when we're looking at our possibilities, we should write them without the absolute value bars. And then 2p minus 3 could be equal to negative 7, and we want our or in between there, or or in between there. Solving both equations. And so our possibility here is that p is equal to 5, or the other value that will work. We solve for that. So the other value that would work would be 2. So the two values that would work for that equation are 5 or negative 2. So we can graph those. It's 5 there. Negative 2. Now we're not graphing greater than or less than, we're just graphing points. So we would graph negative 2 and 5 just as points. So for our third example in this part, we are looking at our possibilities. Our absolute value bars are isolated, so we can decide that this is greater than. So we're looking at an or a union of sets. So just jotting that down. And so I want to split our possibilities. So we have 10 minus 2k is greater than or equal to 6, or 10 minus 2k flipping less than or equal to opposite negative 6, and then solving for our possibilities. So here I would subtract 10 from both sides. Don't forget to bring down that negative with the 2. That gives me negative 4 on the right. Then I would divide both sides by negative 2. I want to remember that when I divide or multiply by negative with inequalities, that I need to flip the relation symbol. And so I get that x or k is less than or equal to 2, or, and I have my other possibility to work on, I'm going to subtract 10 from both sides, bring down that negative with the 2, I get negative 16 on the right there, dividing both sides by negative 2, and I got equal there, I need to change it to less than or equal to. And then, so k is, and now because I divided by a negative, again, I'm flipping the relation symbol, and I get k is greater than or equal to 8. So I want all the values for x that are less than or equal to 2 or greater than or equal to 8. So I'm going to graph those. I just like to put 0 on as a reference. would be 8. And so then as I'm graphing that, so I need things that are less than or equal to 2. So I want a closed circle on 2, and less than means shading to the left. Or I want the values that are at 8 and or greater than, so shading to the right. All right, make sure to bring any of your questions in to your algebra teacher.